Hi everybody. In this video we are going to talk about using tables, organized lists, and tree diagrams to show all the possible outcomes, all the possible combinations of outcomes of multiple events. And we're also going to be talking about what's called the counting principle. Okay, so when I say multiple events, I mean, let's say I have a coin here. What are the outcomes that are possible when I flip the coin? Well, I could get either heads or tails. Okay, but maybe I don't want to just flip a coin. Just flipping a coin, that's boring. That's too easy. I want some excitement in my life. So I will flip a coin and I'll roll a die. So what are some possible combinations? Well, maybe I flip the coin and I get heads, and maybe I roll the die and it comes up 4. So that's one combination, heads and 4. Another combination might be tails and 2. Okay, so using these tables, organized lists, and tree diagrams, we're going to systematically list every possible combination that might happen. Okay, so here's the first example that we'll do. You roll a number cube. Okay, that's this. Okay, it's sometimes called a die. Plural would be dice. If you have just one of it, it's called a die or a number cube. And the possible outcomes are 1, 2, 3. Well, you get the idea. 1, 2, 3, 4, 5, or 6. That's all the different things that could happen when we roll the die. We're also going to pick 1 out of 4 cards. So I have 4 cards here. Let me put those in order, actually. Okay, we have 4 cards here. I'm going to pick one of them. I'm not going to look. I'm going to close my eyes and I'm going to pick one of them. Okay, but I'll either get a jack, which is this guy, or a queen, this one, or a king, or an ace. Okay, so I'm just going to close my eyes and let me shuffle them up maybe. Let's actually do this just for fun. Let's do this. Okay, what's one thing that could happen? Okay, I rolled a 2 again. And let's see, I'm going to close my eyes and pick one. I picked a king. Okay, so that's one combination, a 2 and a king. But what we're going to do now is systematically list every single combination of outcomes that might happen. Okay, the first way we're going to do that is using a table. So to create a table out of the outcomes of 2 events, list all the possible outcomes of one event horizontally and the possible outcomes of the other event vertically. So let me just pause and do that. Okay, so rolling a number cube, what are the outcomes? Well, I'll list those horizontally. So I could get a 1 or a 2 or a 3 or 4 or 5 or 6. And let me list all the outcomes of picking one of the cards vertically. Well, I'm going to just write J for jack, Q for queen, K for king, and A for ace. Okay, and then I'll also just divide these up like this. Okay, now each little square here is called a cell. Okay, so one horizontally and then the other vertically. Okay, we did that. Then fill in each cell of the table according to what row and column it's in. Okay, so that's simple enough. This cell over here is in the column with the number 1 there, and it's in the jack row. So I'm going to put 1J. Okay, so that means that I might roll the die and get a 1. All right, there it is. And I might pick one of the cards and get a jack. Did I get it? Oh my gosh, I got it, yes! Oh. Okay, or what else could happen? Well, this cell here is under 2, and it's still in the jack row. So I might get a 2 and a jack, or I might get a 3 and a jack, or a 4 and a jack, or a 5 and a jack, or a 6 and a jack, or I might get a 1 and a queen. Okay, so that's under 1 there, and it's in the Q row, so for queen. or I might get a 2 and a queen, or a 3 and a queen, or a 4 and a queen, 5 and a queen, 6 and a queen, 1 and a king. That's another possibility. Or maybe I'll get a 2 and a king, 3 and a king, 4 and a king, 5 and a king, 6 and a king. Okay, or I might get a 1 again. I get a 1 on the die and an ace. Oh, can I do it again? Okay. All right, I'm not peeking. Ace, ace, ace. Ace! Ah! Jack up. Where's the ace? There, I did it. Okay, 1 and an ace. Now I'm upset. I was so happy before. Now I'm in a rotten mood and get the ace. Okay, 4 and an ace, 5 and an ace, 6 and an ace. So those are all the possible combinations of rolling a die and picking one of those cards, okay? So that's my table over there. Simple enough. Now let's make an organized list. An organized list is any listing of all combinations of outcomes of multiple events. One easy way to make an organized list is to make a table first. Okay, we did that. And then copy all the cells. Okay, so I don't need, let me draw these let me go over these again in blue actually. I'm not going to be copying these over again or these. Okay, for my organized list, I'm really just interested in these cells over here. So I am going to be copying all of those again. So I could get a 1 and a jack, 2 and a jack, 3 and a jack, and so on. Or 1 and a queen, 2 and a queen. I don't know why I have to keep looking back at the table. It's 1 and a king, 2 and a king, 3 and a king, 4 and a king. Oops. Okay, so everything that I had in here, I just wrote it out here. And again, this is all the possible outcomes, all the possible combinations of outcomes. And finally, a tree diagram. To create a tree diagram, first list all the possible outcomes of one of the events. Okay, so let's do that. Let's do that for rolling the die. All the possible outcomes for rolling the die are maybe we get a 1, maybe we get a 2, maybe we get a 3, or a 4, or a 5, or a 6. When you're doing this, leave some space between these. You'll see why in a second. Okay, and then for each item in the list, draw branches to all possible outcomes of the next event. So the next event is picking one of these cards here. And what are all the possible outcomes for picking the card? Well, I could get a jack, or I could get a queen, or I could get a king, or I could get an ace, okay? And we're just going to do that for each one of these. So jack, queen, king, ace. Jack, queen, king, ace. And again, gets a little bit tedious, not gonna lie. Jack, queen, king, ace. Jack, queen, king, ace. Jack, queen, king, ace. Okay, so what does this mean? How is this, by the way, how is this outcome different from this one? Are these the same thing? Well, no, this means that first I rolled the die and I got a 3, and then I picked the jack, okay? This one over here means first I rolled the die and I got a 1, and then I picked the jack, right? This over here means first I rolled the die and I got a 5, then I picked a queen. This means first I rolled the die and I got a 4, then I picked an ace. Okay, so I think you get the idea. So this is all the possible combinations of outcomes. And by the way, now we might ask the question, well, how many outcomes are there? How many different combinations are there? Well, let's count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. You can see I get the same answer no matter which depiction I used. So there are 24 combinations in the organized list also. I just took these from here, right? So they should be the same. And in the tree diagram, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Again, we get 24. Now, some of you might be looking at me kind of weird, like, Mr. Friedman, isn't there a quicker way that we could have figured out that there are 24 combinations? Did you really have to count every single one? And you're right. No, I did not have to do that. And that is where the counting principle comes in. So a smarter way for me to have figured out how many combinations there are rather than counting every single one is this: to calculate the total number of outcomes or combinations of events, multiply the number of ways each event can happen. Okay, so how many outcomes are there for me rolling the die? There are 1, 2, 3, 4, 5, 6 different outcomes, and there are 4 different outcomes for picking a card, right? Well, 6 times 4 is 24, so I could have just done that, okay? You probably did something like that when you were in elementary school, first learning what multiplication was. Maybe your teacher gave you a picture that kind of looked like this and said, okay, well, if there are 6 squares this way, and if there are 4 squares this way, then how many total squares do we have? Well, that would be 6 times 4, okay? So pretty simple. If this can happen 6 ways and this can happen 4 ways, then the total number of combinations is going to be 6 times 4. And you do the same thing. We could have figured that out also just by looking at the tree diagram. So how did we make this tree diagram? First, we listed all the different ways that all the different outcomes for rolling the die, and there were 6 different outcomes, getting a 1, 2, 3, 4, 5, 6, and then we drew 4 branches underneath each of those 6 outcomes. So the outcome of rolling a 1 had 4 branches coming out of it for the jack, the queen, the king, and the ace. The outcome of rolling a 2 also had 4 branches coming out of it, 1, 2, 3, 4. So if each of these 6 outcomes here has 4 branches coming out of it, then how many branches are there altogether? Again, instead of me actually counting every single one, we could just do 6 times 4, and that tells us that there are 24 combinations, okay? So that's the counting principle. And let's just do one more example now. This time you flip a coin twice, okay? The outcome for each of those flips is either heads or tails. So I'm going to flip this once, and I'll get either a heads or a tails, right? I got a heads that time. Then I'm going to flip it again. And again, I can either get a heads or a tails. Let's see. Oh, I got a tails that time. Okay, so we're going to flip the coin twice, and then we're going to pick out one of 3 cards. This time, the jack, the queen, or the king. So let's get rid of that ace there. Alrighty. So show all of the possible combinations of outcomes and state how many there are. So we're not going to do a table for this one. Oh, whoops, I'm going the wrong way. Let me go back to table. Okay, so we're actually not going to be making a table for this one. And the reason, notice that over here for table, I just said 2 events. So drawing a table is not so good if you have more than 2 events. In this case, the first thing I'm going to do is flip a coin. The second thing is flip the coin again. And then the third thing is to pick one of those cards. So there are 3 things that are happening, not just 2. If I were to draw a table, the table would have to be 3-dimensional. I would maybe have to put the outcomes of the first coin toss horizontally, the outcomes of the second coin toss vertically, and then for the card, for choosing the card, I would have to do something maybe going into the page. So I would have to have sort of a three-dimensional table, which is pretty hard to draw. So we're not going to do the table for this one, but we can still do an organized list and a tree diagram. Actually, I'm going to do the tree diagram first. So when I flip the coin the first time, then I can get either a heads or a tails. So let's write that. Then I'm going to flip the coin again. And again, I can get either a heads or a tails. So I'm going to draw branches out of this heads over here, and again write H for heads and T for tails. So this means that I got a heads on the first flip and a heads on the second flip. This means I got a heads on the first flip and a tails on the second flip. Okay, and I'm going to do the same thing over here. So this was for the first coin toss. I got a tails that time. Maybe I'll get a tails and then a heads on the second coin toss. Or maybe I'll get a tails on the first coin toss and a tails on the second coin toss. Oh, by the way, now it's my, now I get to fool every single person who's watching the video right now. Do you like football? What comes first in a football game, the kickoff or the coin toss? If you said coin toss, you're incorrect. It's coin toss, not coin toss. There's no such thing as a coin toss. You said coin toss. Yes, you did. Okay, anyway, now what's the next thing? Now we're gonna pick one of these cards here, and it's gonna be either a jack, queen, or king. Let's go for a king. All right. Okay, so we're gonna draw a branch out of each of these. Jack, queen, king. Jack, queen, king. Jack, queen, king. Jack, queen, king. Okay, so there's our tree diagram. Okay, what does this mean over here? This means that, let's look at how we got there from the beginning of the tree. Let's say the root of the tree. We got a tails on the first coin toss, a heads on the second coin toss, and then we picked a jack. Or this one means we got a heads on the first coin toss, tails on the second coin toss, and then we picked a queen. This over here means we got a tails on the first coin toss, then a tails again for the second coin toss, and then we picked a king. So these are all the different combinations of things that could happen. And now let's make an organized list. And we can actually, we don't have to do the tape. We could actually make the organized list by reading this off the tree diagram. So heads, heads, jack, that's one combination. Heads, heads, queen. Heads, heads, king. Heads, tails, jack. Heads, tails, queen. Heads, tails, king. Tails, heads, tails, heads, jack. Tails, heads, queen. By the way, I only started on the next row here because I ran out of room over here. It really doesn't matter where I make the next row. I'm just listing everything right now. Tails, heads, queen. Tails, heads, king. Tails, tails, jack. Tails, tails, queen. Tails, tails, king. Okay, so those are all the different combinations. Now, how many different combinations are there? Well, we can count them. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Notice that when I'm counting off the tree diagram, I only have to count the last row here. I'm not counting, if you count these also, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, that would be incorrect. We're only counting the last row because each of the letters here in this last row already includes the information from the rows that came above it. So for example, this king here already includes this tails and this heads. I don't have to count that again. Okay, so I'm just counting this last row here, and that was 12. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, is there a faster way I could have figured that out? Yeah, of course. Again, I can use the counting principle. So the first thing that happened was I flipped the coin, right? That could happen in two different ways. Well, there are two outcomes there, either a heads or a tails. Okay. Second thing that I did was I flipped the coin again. And again, there are two outcomes there, heads or tails. Okay, so 2 times 2 is 4. And that's telling me that if I were to stop there and I didn't do the cards, then there would be 4 different outcomes. Heads, 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 tails, tails, heads, or tails, tails. That's these 4 over here. But then if I also choose one of those 3 cards, well, there are 3 outcomes there, so I'll have to multiply this by 3. So 2 times 2 is 4, and then times 3 is 12. Okay, and you can see these 4 outcomes here each had 3 branches coming out of it. So it makes sense that I should then do times 3, right? 2 times 2 gives me these 4 over here. And then if there are 3 branches coming out of each one, then I should do 4 times 3 to figure out how many combinations there are total. Okay, so that's the counting principle. Just take how many different ways each thing can happen and multiply it all out. Okay, so that's it. Yeah, so that's it. I'm going to end the video there and have a great day.